When working with types, there's going to be times when you need to do casting. And no, I'm not talking about fishing. Casting is when you take one type and convert it into another type. Let's take an example. Let's say you are writing a program to calculate the age of people. It's rare for a person to live over the age of 120, so you use a byte to represent a person's age. A byte is a type that has a range from 0 to 255. Your program does so well that you are asked to adapt it to animals and plants, and right away you run into issues. Well, the byte works fine for people and animals. It fails when it comes to, say, trees, which can live for thousands of years. So you need to take your byte and convert it into an int. Believe it or not, we get this for free. C# has no problem converting a number type to a type that contains more information. A byte contains values up to 256, whereas an int can contain numbers up to 2 billion. There will be no information loss. Simply define an int and assign your byte to it, and voila, you're done. But what if you wanted to convert an int to a byte? That is, convert a 32-bit number into an 8-bit number. You can do this, except you're going to lose a lot of information. This is a dangerous operation, so you need to authorize this, and you do this by a cast. To cast a number, you simply provide the number type in parentheses before the number. This tells C# that you are aware of the danger, but you also adhere to a YOLO lifestyle. That is, you only live once. Oftentimes, you need to cast to a different type right out of the gate. For instance, if you want to create a float and assign it a number, but right away the compiler informs you that a double cannot be converted to a float. Yet you aren't using doubles. Or are you? Well, anytime you type a decimal number in your code, otherwise known as a literal, C# assumes that to be a double. To make it a float, you must cast the number, so you wrap it in parentheses, but a shortcut is to put the letter F after it. This does the same thing as a cast, but it just makes it easier to work with. Let's see this in action.
Often in your C# programs, you'll be converting types from one type to another type. This is just a normal part of working with the language. So it's important that you get comfortable with it. So we're going to demo some of these casting procedures now. So here I have my solution open and I have program.cs open. I'm going to select all these here and I'm just going to delete these. We'll start things off by creating a number. So we'll make this an int. It will be a number and this will be 20. So if I create another number and we make this 30, what the compiler does is it sees 30, and 30 is what is known as an int literal. It is always assumed to be an integer. So when the compiler sees this, it knows that this is an integer, so it knows that this variable is a type of integer. Now with doubles, we'll just call this one a double. When we do something like this, the compiler also knows that this is a type of double because it has a floating point in it. So when it sees this floating point, it will always assume to be a type of double. Now for the most part that works well, but when you're working with floats, you need to signify that you are using a float. So if I do a float, we'll call this a float, and we assign it, say 540.4, well, this number is a double here, and we're trying to assign it to a float. And this is actually a potential place for an error. A double can contain 64 bits of information, whereas a float can only contain 32 bits. So there is a potential that the number is just simply too large for the float to contain. In this case, we know it's fine, and we can shorthand this by putting an F at the end. And this satisfies the compiler. And this also converts this double to a float. Now there are other types of the suffixes that you can add, for instance, when working with longs. We'll just call this a long number, and we'll say this is 430, and we can put an L after it. And by doing that, this int right here is converted to a long. Now you can also use a lowercase l like this, but oftentimes that's easily confused with a number 1. So to avoid that, we always try to use the capital L. Now there's going to be times when you're working with decimals, and decimals are great for currency. So we'll create a decimal number. And again, we run into the same problem. So if we do 432.3 here, this is a double we're trying to assign to the decimal. So we can do this shorthand, which is a capital M, like so. And this converts this number to a type of decimal. Now there are other suffixes as well, so definitely check out the Microsoft documentation on suffixes to see what's available to you. But if you don't want to use a suffix, you can just do a simple cast operation. So what we can do here is we can get rid of this M. Now we're going to get our error again. What we can do is right before the number, we can just add the type. So now we're signifying that we want this number to be converted to a decimal. And so what we're doing is casting it. And you can do this between various types. So let's take another double. And we can cast from a float to a double. And we'll use our float here. And you'll notice that there's no error. In fact, we can do something like this. And that really has no effect. Let's go back to here. So why aren't we getting an error from going from a float to a double, but we got an error from a double to a float? Well, remember, a float is smaller than a double. So the largest float can fit within a double. There's going to be no issues where we could potentially lose data. So in this case, a cast isn't necessary. It's only when you're going from a really large type to a really small type. What is happening here is that the compiler is automatically casting it for us. And we can see this with a type of long. Here we're passing in a 32-bit number to a long, which I think may be either it is a 64-bit signed integer. So we're taking our 32-bit integer and moving it to our larger integer, and yet we don't need a cast. But if we did the exact opposite, like so, we get an error because a 64-bit cannot go into a 32-bit number without losing information. So in this case, we need to convert it to an int.
Casting is a key component in C#, but you'll be happy to know that we do not have a cast system here at the raywinderlich.com YouTube channel. All are welcome to learn, and if you like that, make sure to let us know by hitting that like button.